All right, in this video lecture, I'm going to go over linear interpolation motion using G-code. So the linear interpolation motion is used to cut in a straight line to a position relative to your work offset, if you've already stated what your work offsets are. All right, and you set a feed rate. So maybe I'll just add a little bit onto this sentence right here. So cut in a straight line to a position relative to G54 with a specific or specified feed rate. And that really sets this motion apart from a rapid motion, which is a G00 function. As we recall, a rapid position motion is, or rapid motion is G00, and that will send the tool wherever you command it to go at the maximum speed that the machine can go. All right, but G01 sets it apart that we can actually have a feed rate. Okay, so we have a feed rate specified right here, and that is in inches per minute. All right, so you would tell this tool to go to Z negative 0.25 at 5 inches per minute. So you're telling it a speed in which to plunge in the Z direction. All right, so right here we have the go to the position or location with respect to G54. And it's not always going to be G54. You may have other work offset positions, maybe G55 or G56. There are a couple you can choose from, but I'm just using the example of G54. And of course, this G01 right here is the linear interpolation motion. Okay, so let's take a look at this tool right here. We can see that if we were to use this code and this tool was in a position, above Z minus 0.25, so let's say this point right here is X equals 1.500, Y is equal to 0.2500, and Z is equal to 0.200. So let's see what this code would do. This code would tell this tool to move to a Z position of negative 0.25. So it would actually tell the tip of the tool to go down to this point right here. So it would go to X equals 1.500, Y equals 0.2500, and then it would go to a location of Z equals negative to 0.250 inches. So you can see that with this code, the X and Y position stays the same, and really only the Z changes because you've only told the tool to change to a different location. All right, let's take a look at another example. All right, so let's say we have, this position is, we're going to borrow from the previous position. Let's say it's right here, and it is at, it's at X equals 1.500, and the Y is at 0.250, 0, and the z is at negative 0.250. So this is just where we're picking up from our previous position. And now we're saying to we're just saying to use the G01 linear interpolation command, and we're saying go to x equals 0.000 at a feed rate of 15 inches per minute. So we're actually telling it to go a little bit faster than the case above, which was just 5 inches per minute. So we're saying go a little bit quicker to the x position. So where is that going to end up? Well, it's going to go along a path backwards, right? So it's actually going to go to this location right here. It's going to go along the x-axis to a point of x equals 1.000, y is equal to 0.250, and z is equal to negative 0.250. So we've really only told it to change in the x position to go to, go to x equals 1.00 with respect to G54. And it didn't tell it to go in any y position, so it just stays at y equals 0.250, and the z stays at negative 0.250. So, all right, so let's look at one more case here. Let's go to one more case. All right, so here we see that we're using our linear interpolation motion, a G01, and we're saying to go in an x direction and a y direction. Okay, so what's going to happen is this is going to go on a diagonal. The tool is going to go on a diagonal. Take the shortest route to this point from its current position. So it's a diagonal cut. And notice that there's no feed rate here, no feed rate. And when there's no feed rate specified, you'll just use the latest feed rate that was programmed. So in this instance, we're still going to move at a feed rate of 15 inches per minute. So let's take a look at where we are right now. So we're at x equals 1, y equals 0.25, and z is at negative 0.25. Okay, so let's just write it where the current position is. This point right here at the center of the tip, at the bottom of the end mill, is at x is equal to 1.000, y is at 0.250, and z is at negative 0.250. And so we're telling this to go in two different directions at the same time. So we're telling it to go along the x-axis this way, and in the negative direction of the y-axis this way. So this point is going to go in a diagonal, past the 0 point. Maybe if this is the 0 point, maybe it's going to go, below the x-axis line here, because it's going in the negative y point. So it seems like it might end up actually down here somewhere. But anyway, we're going to take a diagonal path, the shortest point between its current position, which is right here, to this x 1.5 position and this y negative 0.954 position. let's take a look of where it will end up. So it's going to equal, x is equal to 1.500, y is equal to negative 0.954, and z is equal to still negative 0.250, because we still have not told in this code right here, to move the z location. And we're going to go at a feed rate of 15 inches per minute, because we did not specify a new feed rate. So it just picks up the feed rate from the previous block of code. Okay, so that's how linear interpolation motion works. It's good for moving in single directions or diagonal directions. All right, so this concludes the video on linear interpolation motion.